Hi everyone, we're going to start our conic section, and the first thing you need to know is the distance formula and that it's based on the Pythagorean Theorem. So if I have this triangle here and I want to know what C is, I know the length of A is 6, so I'd get 6 squared plus 8 squared equals C squared. So this is 100 equals C squared, so C is 10. Well, the distance formula results from the same thing, but instead of calling it C, we're going to call it D. So D squared equals A squared plus B squared. So we already know that this is 10. And we want the distance between this point, we'll call this point 6, 0, and this point up here, which is 0, 8. And I'm going to call this point 1 and this point 2. And so therefore, this would be x of 1, comma, y sub 1 for point 1. And this point would be x of 2, comma, y sub 2. All right. So basically what I'm going to do is my A equals my A, and this is going to be called x of 2 here, x of 1 here. So x of 1 is 0. No, let's erase this part real quick. All right, I'll do that in a minute. So this is x of 1, x of 2. This is y sub 1 and y sub 2. So what I do to get 6 here is I subtract x of 2 minus x of 1. That would give me 6 minus 0 is 6, which is what we had here. And you square it. And then plus the b part. My b part is my y. And that's going to be y sub 2 minus y sub 1. All right? And then to just find d and not d squared, I square root both sides. That's supposed to be squared. And there you get distance equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Now, of course, you don't always want to draw everything, and this was an easy one. So we're going to do some problems where they're bigger numbers and more complicated. At the end of the video, I'm also going to do a umbrella in a box and find a diagonal. Okay, so that's going to be at the end. I'll try to go quickly on this. All right, so we have point 1, which is called x sub 1, y sub 2, point 2, which is x sub 2, y sub 2. This is y sub 1. And I'm going to use my distance formula to find the distance. And we don't have to draw. So this is x sub 2 minus x sub 1 squared minus y sub 2 minus y sub 1 squared. You plug everything in. So x of 2 is 6 minus a negative 3 squared minus, no, this is supposed to be plus 11, negative 11 minus 4 squared. So we get square root of, we get 9 squared plus a negative 15 squared, which equals the square root of 81 plus 225, which equals, what is this? Square root of 6, 10, 306. We can reduce this as 9 times 34, So we get 3 root 34. Okay, so that is that one. Here's another one, and I'm just going to go ahead and plug it in. So y sub, well, let's do x first. X of 1 minus x of 2 plus y sub 1, or y sub 2 minus y sub 1. And that gives you negative 2 squared plus 6 squared, which gives you the square root of 40, which equals the square root of 4 times 10, which equals 2 root 10. And I decided to do one that's a little more complicated, that has radicals in it. So our distance is, okay, I'm going to take my x of 2 minus x of 1. Okay, and then take y sub 2 minus y sub 1. And square it. All right, so this one right here is really 3 times 4 times 2. Just times the square root of 4 times 2. So square root of 4 is 2. So 2 times 3 is 6. So this is really 6 root 2 here. So when I rewrite this, I'm going to rewrite that. So here we have negative 5 root 5 squared plus, and this is now going to be 6 root 2 minus 4 root 2 squared. These two quantities have to be the same. It's like terms. Now I'm going to fix this up again. And I get, I square this, that's 25 times 5, plus, this is 2 root 2 squared. So it's going to be 4 times 2, which is 8. All right? And then we get, which one is this one? Okay, well then we get 25 times 5 is 150, so that's 158. So we get the square root of 150. Is that 158 or 130? So 25 times 5. So 25 times 5 is 150, so that's be 158. Okay? Now the next one I have is where we have to find C. So they give you the distance of 5, and you have to find C. So we have 5 equals the square root of C minus 5 squared plus negative 3 minus 2 squared. So 5 equals the square root of, I'm going to keep this the same. This is going to be 25. Because negative 5 squared is 25. Now I'm going to square both sides. You square both sides. Get 25 equals square root. Well, actually, this goes away. So you get C minus 5 squared plus 25. All right. When you subtract both sides, you get 0 equals C minus 5 squared. I'm going to square root both sides. So I get 0 equals C minus 5. Add 5 to both sides and you get C equals 5. And that's how you solve for that. And a lot of times you can get 2 solutions on this. So here we have another one. I'm trying to find which one this is so I don't make a mistake. All right. So we have 5 as our distance. The square root of 2 minus a negative 2 squared plus negative 1 minus C squared. All right. So we have 5 equals the square root of, this equals 4. So that's 16 plus negative 1 minus c squared. I square both sides. So we get 25 equals the square root of, well, when I square both sides, I don't have square root on this. When you square both sides, this square root goes away. So you have 16 plus negative 1 minus c squared. All right, now I'm going to add the 16. I get 9 equals negative 1 minus c squared. Now I'm going to square root both sides. When you square root both sides, you get plus or minus 3 equals negative 1 minus c. So I'm going to add the 1. Actually, I'm going to, okay, I'll just do it this way. So you get plus 3 plus 1 equals negative c, and negative 3 plus 1 equals negative c. So what we're going to get is 4 equals negative c, so that means negative 4 equals c. And this is going to be negative 2 equals negative c, so that means c equals 2. Now when you plug both these answers in, they both work. So you have 2 solutions that give you that distance. Okay, here's one more. We're going to still say the distance is 5. And I'm going to subtract my x's first, and then my y's. And then clean it up here. Equals 25. Okay, I'm going to, equals 5, I'm sorry. Now I'm going to square both sides. When you square both sides, you get 25 equals negative 4 minus c squared plus 16. I'm going to subtract 16 from both sides. So you get 9 equals negative 4 minus c squared. You're going to square root both sides. Now remember, when you square root both sides, you do plus and minus. Looks almost like the other problem. Get plus or minus 3 equals negative 4 minus c. And this time I'm going to do it a little different. I am going to move the c over on this side and make it positive. Keep my negative 4 here, and then subtract and add the 3. So we have c equals negative 4 minus 3, and c equals negative 4 plus 3. And this equals negative 7, and this equals negative 1. And if you plug that in, it should work. Okay, the last problem is the problem with an umbrella. And a lot of times on SAT tests, although they're changing, they ask you what the length of this diagonal from the far end of the box all the way to the other end of the box. And simply we're talking about we're in 3 space or 3-dimensional. And you're just going to use Pythagorean Theorem as such. D squared equals A squared plus B squared plus C squared. So D squared equals, and you can call these whatever you want. I'll just say 4 squared plus 3 squared plus 5 squared. And then you take the D, take the square root of both sides, and you get that. So I think I already did this. Did I do it? No, let's see. So yeah, and when you do that, you get 7.07 equals your D. It's very simple, but I see a lot of students that don't know how easy this is. Okay, the next thing we're going to talk about is midpoints, and then we're going to talk about circles. Thank you, and have a nice day.